to know how to use it. Does that make sense? Will I give you area sector, area circle though?
Yeah.
We'll go back over.
I don't remember.
So what I want to do here is just kind of talk about how we can sit here and work with this projectile thing, what this means. Where is the one I wanted to do here?
Why is it?
You keep pressing buttons on your watch, it's annoying. All right, anyways.
Yeah, I was just.
So here's what I want to do. I want to walk you through how these things work. If you're talking about a projectile distance thing, you're looking at how far something's going to go given an initial velocity or an angle. You might have, you'll notice that you'll have three variables here. You've got distance, velocity, and some angle. You'll be given two of those three. More often than not, you'll probably be given velocity and a distance. Maybe you have to find theta. Sometimes you might have to find, you'll probably be given theta, find velocity. It's not that crazy of a formula to work with. So what we've got here is, again, two people kicking a soccer ball. 42 feet per second is the initial velocity. Yours is at, because everybody goes out to play soccer with a compass and a protractor, right? So you have a 45-degree angle and a 60-degree angle. Which one's going to go farther? So what we do here is just mainly distance to the first person.
So basically the sine would be the angle, right?
Yep.
Why did the 60 degree?
That's a theta next to the T, right?
It is a theta, yes.
That's tricky.
What's happening here is you've got that 2 times 45. You're finding the sine of 2 times 45. And then you're finding 2 times the sine of 60. So you have two different ones to work with. And again, this case here, we're talking about it in terms of degrees. You don't have to worry about converting anything into radians at all. Very trusting of her. I wouldn't be. So when you substitute this stuff in, again, what's the sine of 90? 1. So that's going to be an easy one to work with. So 42 squared, hit enter, divide that by 32. This one went 55.125. Again, you can type this into it with the alpha y equals and create this whole string if you want.
What the heck?
I don't know. Oops.
I got 77.
Are you in radians?
No, and I just checked it too.
What's 2 times 45? Yeah. Yeah. I'm multiplying that through, doing that in my head.
Oh.
Put your watch outside, please. Okay?
You should see when he does the Jake setup.
Again, when you're dealing with when you have these simple, when you have the simple thetas, just do the multiplication real quick and enter it in the calculator straightforward. Okay? you'll notice these problems are going to be ridiculously straightforward.
Wait, so
Really easy.
I got
42 feet per
55.125.
second, then your answer is 55 feet.
I did it right.
Again, what I'm looking at here is, in this case, you're finding distance. A lot of times you might be solving for the velocity. If you have to solve for the velocity, you'll notice that the velocity is squared. So when you work that through, you might have to take a square root at some point in time. It's
7.39.
okay.
Okay, so,
Oh, wrong one.
can I ask a question?
Yes, sir.
So when you're putting it in the calculator, do you put the 2 and the 45?
It's multiply. Just do. You can if you want. Because when you hit sign, it opens a parenthesis right away. You can just do 2 times 45, close it, and do it that way. Or is it sign at 90? You can do that too.
Thank you.
Not a problem. Now, the other thing I know you guys were asking, if we go back and look at where we were with the areas of sectors and areas of circles, this is one of the questions you guys were questioning about here. Quick review with the arc lengths and sectors. Hit the wrong button. What was the formula for arc length? You remember?
Beta times R. I mean,
They are times
beta.
theta.
Something with theta, right? All right. How do you spell theta? Theta. Now, just a quick reminder, when you're working with arc length, it was S R times theta. What did theta have to be whenever we were working with these?
Less than 90.
No.
The number.
What was theta?
A cube.
Bless you. You said it. Got you. No, it's theta was always in radians. Okay. This was always done in radians. Okay. So theta was always in radians. So you might have to do a conversion here. If I'm looking at this first one, do I have to convert anything? Try to give it to me in terms of radians. Okay. So here it's just,
Even if it's given in degrees, you still want it.
you always give it in radians. Yeah, these things will always be done in radians. So here we'd have 5 pi over 2.
8.
Okay. If I'm in degrees, what would you have to do differently?
12 times 5.
So you have 12 times.
No, that's not 5 over 4.
5 over 180.
Yeah.
I'm looking at arc length right now. Just do an arc length real quick. I'll do the area here in a second. Now, remember, you can simplify these things before you multiply it out. 12 and 18 are both divisible by what?
10.
Think bigger. 10. 6. 25 and 30 are both by 5. 10 pi over 6. 5 pi over 3. Okay. In your calculators, if you multiply everything out, math, enter, it'll work out for you. Just remember to put pi in your answer. Now, when you're dealing with the area of the sector, you okay?
He's called Jago.
I can't imagine why.
This is a mystery.
You all right?
He's not well.
Oh, I know that. It's just like you being all right.
I'm more alright. It's too long over here.
Yeah.
You know what's really funny?
I don't know.
Highlighter.
Were you sniffing glue for breakfast?
Sniffing coke.
He went to Scarface.
He was a Scarface. He was measuring the angle of repose. Oh, he was.
Then he accidentally.
Is it June yet?
No. I'm still stuck with me.
It's 1/2 r squared times theta, I believe was the area of the sector, correct?
Is that over 180?
And again, you just have to substitute all their stuff in. What's that? It's the same thing. So it just matters substituting in. Yes, sir.
Is there 180 in this one? Do you do anything?
Again, theta is always in radians.
Okay.
Okay. So you might have to convert it to radians. It's given it to you if it gives it to you in degrees right off the bat. You have to make sure you put that into the radian form. Okay.
Can we see an example of that?
No. I have theta at 210, a radius of 16. I'm going to find the area.
Put Jason in the hall.
We might have to. It needs to time out. 1/2 of 16 squared times 210 pi over 180. Again, as you simplify that stuff through, 16 squared is 256. Half of that is 128. I can do that real quick. I can also divide 18 and 21 by 3. So I have a 6 and a 7. So it's 128 times 7 over 6 with a pi. I divide them by 2. I get, let's see, that'd be over a 3. 64 times 7.
448 pi divided by 3.
Okay. Remember, if you put it all in your calculator, math enter, just don't put pi in it, it'll work.
I don't trust calculators and do this
Good. Then do it my way.
stuff. I agree with my
All right. And it'll work out. Just be very cautious as you simplify it through. Yes, sir.
On the test, will it say like,
Whenever it's something you need to remember always. Yes. When you're dealing with arc length and area of sector, it's always in radians because the formula itself is given to us in terms of radians. We had a great question, guys. There have been parts of this chapter where we had give you an answer in radians, give your answer in degrees. Whenever you're dealing with arc length or area of the sector, that was always a radian problem because the formula was presented to us in terms of radians. Okay. Okay. Let's do this then. I've got that pseudo review stuff. It's got some of the arc length stuff on there. I don't think I hung that up. Somebody else.
You still have my dinosaur?
So let's take a look at some of these. One of the things that, like I've said here, that's not on here, there isn't really a good variance of any of these word problems that I want to look at. What I'd like you to try, here with this angle of, not angle, the velocity ones. This is in 13.3. On 789, take a look at a couple of them. Let's see, what were the good ones? It was like 70 and 69 or two others that had that very simple formula to them to work with. So on, was it 789 I said? Try 69 and 70. I'd start working on this stuff here. Again, one of the things on here is you want to try and do as much of this as you can without a calculator. It wouldn't be a bad idea. I gave you the answers on this, so you guys can find out the stuff's really easy. The other thing I'm going to suggest that you don't have a copy of, if you go to the chapter review, the chapter review goes back to talking again about 13.1. We did 13.1 a few weeks ago prior to doing law of sines and law of cosines again. We kind of breezed through that. We talked about the 6 trig functions. If I give you a triangle, you should be able to generate the 6 trig functions from the triangle, just by writing it out. Also, when you get into 13.2, there's your radians to degrees, degrees to radians, arc length, trig functions of adding angle, evaluate without a calculator, stuff we've been working on, inverses, stuff we've been working on.
That was the stuff we did on the
Yes, sir. Now, the stuff that's not on here, the stuff that's not in this that I couldn't find extra problems for. If you think, what was it, 13.1, 13.2, might have been 13.2.
So wait, would you find a reference like, oh.
In section, I want to say it was 13.2. Nope, it was 13.1.
We had some problems with it, but
Ah, there it is. In 13.3, remember how you were given a set of ordered pairs? And then you had to evaluate the 6 trig functions given the ordered pair? If I look at this one and I want to start at -12 and -15, and I want to write out the 6 trig functions given that set of ordered pairs. If I set that up, remember, what quadrant does that drop into? It drops to the 3rd quadrant. So here's -12 and -15. Remember, theta always goes to the origin. Theta will always be on the origin. Therefore, what is my adjacent?
Well, it would be the, no, that would be 12 right there on the x-axis.
My 12,
And
15, my
that would be
15,
and then that would be,
whatever my hypotenuse is. This is going to be your R value.
yeah.
So you're using your x, y, and R, remember, was the square root of x squared plus y squared. And then you get your 6 trig functions off of that. This is 13.3. That was when you had theta and standard conditioning on the terminal side, things like that. Okay. So just a quick reminder on that one. It's not in the review, which is kind of weird. It's kind of an important topic as we went through. And go from there. Can't think of really anything else to tell you guys that, we'll go over some of these tomorrow. We'll go over some more of this stuff tomorrow as well. We'll give us a good setup ready to go for Thursday on the test. God forbid that we really do get 7 inches of snow tonight. After midnight.
Wait, we didn't get snow maybe?
It was, are you kidding me? No, they're talking 3 to 7, somewhere on those lines. If, just so you guys know, if by chance there is a pause in our academic day, we will still have the test on Thursday.
Better not.
Just so you guys know. Just so you guys know, we cannot have the test on Friday because I don't have a 12th hour class Friday because of that ice cream thing. So the test has to be on Thursday no matter what. If the locusts swarm tomorrow and they all eat everybody, we will still have the test tomorrow on Thursday.
It'll be a perfect day.
If they shut down the school for latest cocaine business, then I will email you guys all a copy of the test.
Wait,
and
you
hope
have
the
one
fact
too?
that you will not hope that you will not cheat.
wait, we have a cocaine business?
Wait, what?
You're not in on it?
No, we don't. How else do we afford these snappy things? Yes, sir. I still remember